Okay, I am in the same team as Maria Jones, who was presenting in the panel before lunch. And I am going to talk about some public tools that our team has developed. This is not only our work, but the work of also the other members of our team. And this is what we have developed to make initially, the purpose with this was to make our work faster and to make it more efficient. But eventually, this also became a public Stata package that is now public. You can install it and use it in your work if you code in Stata. And I am going to explain what this is. So first of all, why is this in Stata? Of course, if we are about transparency and reproducibility, why are we using proprietary software? The reason is because most of the work that we analyze internally for the reproducibility initiative of the World Bank is in Stata. That's 77%. We have seen that the rates of use of other software has increased in the last years, but still the majority is Stata, and this is very in line with other, for example, reproducibility verification initiatives, like for example the one from the American Economic Journal. Only 18% of these works are reproducible at first try, so we created a Stata package that has several commands that make the work of checking reproducibility easier. And that's this. Repkit is the name of the package, which contains 4 commands that I am going to talk about in the next minutes. So the first is called reprun. And the idea for this command came one day when we were brainstorming wishful thinking in our team. And what we wanted, so what we have observed in Stata code is that sometimes you run your code, and maybe this has happened to you before. You run your code, you generate outputs like some regression tables, for example, but then you run it again, and your results change. Okay, and then again, and they change again. So I have been checking reproducibility in Stata for almost 5 years by now. And when I saw that this was happening, especially in the beginning, what I had to do is try trial and error and see exactly what was the first line when the results were starting to diverge. Because that was the line that was telling me, okay, so there is an unstable sorting and uncontrolled randomness, and I can know how to solve this, to propose it to the authors. So reprun, what it does is it runs a do file twice, and it saves the data signature for each of the runs line by line. And it will tell you where those data signatures between the 2 runs are starting to be different. This is a short example. So the code to the left here, what this is doing is, this is creating an unstable sorting. So this is a sorting that if you don't control well, is going to give you one sorting for the first run and another for the second run, and then this is dropping observations based on the order, the unstable sorting that it creates. So if you run reprun on a do file that is doing this, this will tell you that your data signature is starting to change in line 193, so that you can correct this if you want to achieve computational reproducibility in your Stata code. And this will save you a lot of time. So it does for us, especially with things on reproduce and we want to know what's going on. So that's the first of the commands. The second is reproot, which addresses the problem of absolute file paths in Stata. So a lot of people do this when they code in Stata. So you check the username of the computer and then you adjust absolute file paths. They are usually root directories. For example, in our teams, it's very common that people will use one directory for data and another one for code. But of course, this makes that you always have to adjust these paths when you run the code of a project for the first time, okay? So the solution for that is reproot, which instead of having to set up the run and the file paths once per project, you only do it once per computer by indicating, and this also works with a nice interface where you don't have to code. Basically, the only thing that you have to do is select the paths in which you want the command to start looking for your project folders, and then everything is automated. And you do this only once in your computer. If you're working with co-authors, they also have to do it once in their computers, and this will work. So this solves the use of absolute file paths in Stata. The third is to manage dependencies in a simpler way. With dependencies, what I mean is when people code in Stata, they use a lot of user-written commands, like things they install from GitHub or from the statistical software components, the SSC, the famous SSC repository. And The problem with this is that sometimes, you know, the code in SSC especially is not versioned, right? So you install the version that is available as of the day that you are installing the command. But the code is updated, like, for example, bugs are corrected, or functions or options for the command are deprecated, or new functions are added. So we who work in reproducibility observe that if people don't use exactly the same versions, this can create a problem for reproducibility, especially across years, right? And the solution for that is to include the files for dependencies that you are doing when you work with someone, that you're using when you, and when you work with someone else, and you share that for a project, for example, and you can do this with repado, which is the third command of repkit. It's called repado because the dependency files are usually stored in this folder that is C-ado in Windows. And the way you implement this is, for example, if you have a main do file for a project, you can include in that main do file a line that is doing repado pointing to a folder where you have when you have your ado dependency files, and this is going to tell Stata, okay, the base commands are going to come from the usual place, but any user written or user installed commands are going to come from this other location that you're pointing to, and that way, that's like locking the versions of your dependencies, so that works great for reproducibility. And lastly, the fourth command is Stata linter. So linters, they exist across programming languages and across statistical programming languages. So they are tools that detect like things that you can improve in your code or bugs in your code. In our case, the linter for Stata is mostly for the aesthetical function of code. So it basically tells you how can you make your code prettier. And it follows the Stata style guide of our team also. And this is the way it works. So for example, you can have a do file that has very long lines, or that, I don't know, can have very different aesthetical things that are not going very well. You implement this command, the lint, point into that do file, and it will give you a list, and it can also give you the lines of where you can improve your code and improve, in general, have better, better coding for your code to be better understood. And I wanted to bring this, and make a special emphasis in this quote: programs must be written for people to read and only incidentally for machines to execute. Because this is exactly what we wanted to achieve when we published the Stata linter. This also brings me to one of the ideas of Brian's presentation, which is, remember that if publications are digital, the only meaningful output of our research is not a paper, right? Also the code is important, also the data is important. And if the code is going to be public and is eventually going to be made public in a reproducibility package, the fact that it will run only once to produce the outputs of your paper, that's just incidental. The real value of the public good for your code and the real value in what it can be as a public good for others to build on is in it to be understandable for others. So the lint command can help you with that. And with that, well, remember that this exists. Repkit is the name of the package which contains these 4 commands. You can install it with the SSC install command. It's available, yeah, you can do it right now. And thank you.